In this session, in this video, we are going to talk about shear flow and what is the application of shear flow, why we need shear flow to calculate it. Shear flow is used when we have a built-in beams. It means that make a beam by several beams that connect them together. For example, 4 joints here are connected together to make one beam, or here 2 I-beam is connected together by bolts or by welds, make another stronger beam, or making 2 lumber or timber or planks here as a wood, or maybe weld them if they are steel, together make a T-beam. And in this case, we need to know the fastener that we use to connect them together, how many of this fastener we need for our design, and how much must be the space between them. Space between nails here, which is called the S, or in this arrangement, this space between nails is called S, and here a space between bolts is called S. Here a space between, again, fastener or rivets or bolts or a screw is called S. We wanted to calculate S. For S, it means that we have to calculate shear flow fast. We know that at this junction, the fastener or rivet or bolt or screw is in danger of cut. I show danger of cut. Why? Because at the connection joint between these two planks, we have a horizontal shear stress. And we talk about horizontal shear stress in the previous video. Okay? You can find it. Then, in order to calculate S, we must first find out horizontal shear stress that exists at the junction. For example, for this one, horizontal shear stress is here. I can show it by and here between them, if I show the lower part, which is easier because I can see the surface, horizontal shear stress. And continue. And this horizontal shear stress produces shear force, horizontal shear force. You know that. The resultant is horizontal shear force. And if you consider the nails, space between these two, in this area, all this horizontal shear stress can be taken by this nail or rivet or fastener. Here also, if I show the location of nails, then between these two nails, any horizontal shear stress that changes to the shear force, a shear force here, is taken by this nail. Another for this space is taken by this nail. Another shear force is taken by this nail. What happens if there is no nail for the connection? During loading, they slip on each other if there is no nail. And what causes slip on each other? Exactly the horizontal shear stress that generate between them. Maybe you use glue. Glue has the same role as fastener, no difference between them. Then we know what type of fastener we are using, and we know the shear strength of the fastener. We called it Fs. Shear strength of the fastener. How many we are using, for example, it depends. Then you wanted to calculate the horizontal shear stress, tau, which is equal to shear force. It depends on the loading on the beam. You must draw the shear force diagram to find out where it is the maximum shear force, because we are looking for or focus on the worst case scenario where the V shear force on the beam is maximum. We don't pay attention to the other values. And then multiple the area that you separated at the junction. For example, here you separate what? This area. And this is cut, which is recorded in the formula is B. In here, you separate this area because you wanted to find out how at this two junction. And here, you separate this plank because you wanted to know horizontal shear stress at this point. Then, in here, B is this length that you cut. In this design, B is this plus this that you cut. B is this formula. Then Q, I, has second moment of area or area moment of inertia, you know that. And B depends on the amount that you cut to separate one part from others. For example, to separate this part, top flange from this web, you have to just cut in this area. Then the length of cut is B here. And here, if you cut this two to separate the top flange here, you have to separate top and then you have to cut it here and cut it here. This plus this is B here. Remember, because we use 2x10, this 2x10 joist, and this shorter one is 2x6 joist, then 2" here and 2" here, B is 4" here. But here, if you use the same planks, 2x10 and 2x10, this length is 2 inches. B here is 2. Other things that you must remember is the number of nails for each space. From this space and this space, because you calculate B is this length plus this length, you cut it, then you have 2 fasteners here, 2 nails here. You must consider Fs times by 2, because at each row, you have 2 nails. All this force and this force taken by these 2 nails. And this force and this force taken by these 2 nails. Then number is important. Here, this tau is taken by this nail. The resultant is a force. But we must get rid of the thickness. We don't need thickness in calculation of the force. We just wanted, cannot say in the whole beam, horizontal shear stress is this amount, Fs. Okay, what's the use of that? I know the total horizontal shear stress in the whole length of this beam. I don't need that. I wanted the horizontal shear force. Total horizontal shear force doesn't help me in the whole length of the beam. I wanted horizontal shear force in the unit of length of the beam in order to find out how much is belongs of this horizontal force for this length, which is S. If I know the horizontal shear force on meter or on foot or on inches, then I can find out how much force is at S length of the beam. What I must do? Then I multiply it by B. I get rid of B of this formula. How multiple B actually give me what? If I multiply the whole area is tau D dot S. It's the force that taken by this nail. Horizontal shear stress times the area between them. Area is B dot S. B here is this plus this times S. It's 4 here. Here B is 2H here. Is equal to what? Must be taken here by 1 nail. Here by 1 nail, which is equal to Fs. In here, it's taken by 2 nails. 1 here, 1 here. Then we have 2 times 2 inches, 4 inch B, and 2 times Fs. You will see that these two can be cancelled out from both sides. Okay. Then, this value, tau times B, is called shear flow, the amount of shear force that exert in 1 unit length of the beam. I told you I do not need the total shear force along the beam. If I want that, I must multiply the whole area of the span of the beam in tau here. Tau, horizontal shear strength, the whole area. But it gives me the total shear force for the river. Has no point. I just wanted how much shear force we have in 1 meter or 1 foot. And in this case, I know that the shear strength of the nail, and I can say, okay, in 1 meter, I have this amount of shear force. How many nails can take this amount of shear force? For example, I found that 3. It means that the distance between these is 1 meter divided by 3. 330 millimeter or 0.33 meter. In this case, we called it shear flow, which the unit is Newton force per unit of length or meter, for example, or pound per, you can say pound force per inch, times S equal Fs. Shear strength of 1 nail, or we have a 2 nail or 3 nail, you must multiply by S. Then S here is equal to Fs. If it is 1 nail, we can talk about NFS. Then it can be 1, can be 2, can be 3, can be 4. It depends on when we cut the surface, how many nails we are cutting. In here, I cut just 1 nail. And in here, to separate it, I just cut 2 nails. This N can be 1, can be 2, and more. You must look at the design. Then, NFS divided by Q. This Q is what? This is tau. I multiply it by the S in both sides, or I multiply it by B, then Q is equal to V Q over I in general. But we always look at the Q max, which belongs to Q max, shear force in the beam. And this Q max here needs you draw the shear force diagram to find out where it is maximum. In the cantilever beam, at the base. In the simply supported beam also, at the supports. But you must be which supports takes the more actually shear force. And use the maximum value for it. Then number of nails depends on the design. It can be 1, it can be 2, like here on this design is 2, in this design is 1. There is another question here. Which arrangement here is better for us? This arrangement or this arrangement? Both has the same eye, both has the same loading conditions, both has the same material, but we say that the material that use less nails is better. There are many ways. Economic, actually, point of view, or another thing is the material that we use for this building beam. The most of them are wood, and we know that wood is orthotropic materials, and the maximum modulus of elasticity is in the grain, along the grain, and the other which are actually in the other directions, it is the weakest as the lowest. One is in the perpendicular to this, one is the tangential modulus and perpendicular. The other that is the aligned longitudinal, along the grain or along the fibers, this gives us the maximum modules of elasticity for the wood. But what happened? Nails, if you use a screw or board or any holes that you make in the wood, separate this fiber of the wood from each other. And if these nails are very together, crack happen and the wood splits, especially at when beam is maximum, where at the supports. This is one of the mode of failure of joist. In the building, if you look at the joist, you will see some of them close to the support has crack or a split. And notch is another cause of failure. The size of the notch, holes that they make for pipes or wires, electric power wires, they pass through the holes in joist. It must have a minimum distance from the edges and also must have the size is very important. And many things must be considered in wooden beam. Then, you know what is shear flow and what is the application of that. And you can solve many problems for built-in beams and find out the space between nails. Actually, but they must give you what? This characteristic of nails. Shear strength of nails or bolts or a screw, it must be given. You must know when you are preparing from the market, you must know how much is the shear strength of this nail or fastener. Thank you and bye.